A sector of a circle is a part or the percentage of a circle. Basically, we're talking about a percentage of the area of your circle. So if we are talking about a full circle, the sector of a full circle area would be pi r squared. So therefore, if we're talking about the area of a sector, it's just a fraction of the whole circle's area. So in degrees, we use A for area always. We would take the angle divided by 360, which means that that's the fraction of the circle that we are trying to find the area of. For example, if we were trying to find the area of 1/4 of the circle, that's the same as 90 over 360. And 90 degrees of a full circle is 1/4 of a circle. And then we would just multiply that by the area of our circle. So then this is our degrees formula. And you guessed it, well, what happens if our angle is given in radians? We do not need to convert our radians into degrees. We can actually just use a separate formula. And so let's pretend, or we know a full circle is 2 pi radians. So I'm going to put 2 pi in for 360. Whoops. And just rewrite the rest of the formula. So my pi's cancel out, and I'm actually going to write this as a 1/2 times your radians times your radius squared. So this would be the area formula if we were given our angle in radians. All right, let's get started. So the first one here, we are given it in radians. So I'm going to use that second formula. Area is equal to 1/2 times my radians times my radius squared. Now it doesn't say whether we want exact or rounded, so I'm going to do both. So for this one, we have a 12 squared, which is a 144 pi over 12, which reduces to a 12 pi measure area, so centimeters squared. If we wanted to round this to the nearest tenth, 12 times pi is the same thing as 37.7 centimeters squared. That would be the area of that sector. The next one, I'm given my angle in degrees, so I'm going to use the first formula. And I'm given the diameter. The diameter is 2 times the radius, so doing 4 divided by 2, I get my radius is 2. So 2 squared is a 4. A 4 times a 60 is a 240. So I have a 240 pi over 360. Giving it an exact format. Both 240 and 360 are divisible by 120. A 240 divided by 120 is a 2, so I have a 2 pi. And a 360 over divided by 120 is a 3. So 2 pi over 3 centimeters squared. Or if I asked you to round this to the nearest tenth, you would do 2 times pi divided by 3, and that comes out to be a 2.1 centimeters squared. The next one, I'm given my angle in radians, so I'm going to use the 1/2 times my radians times my radius squared. So an 8 squared is a 64 times a 5. This gives me a 320 pi. And then a 2 times a 4 in the denominator is an 8. So 320 divided by an 8 comes out to be a 40. So 40 pi centimeters squared, which is approximately equal to 125.7 centimeters squared. All right, number 13, this time we're given the area of the sector, which is 12 pi, and the angle measures in degrees, and we want to find the radius. So I'm going to use the formula. A is equal to, my angle was given in degrees, so I'm using this formula. All right, so my area is 12 pi, so I'm filling that in. My angle was 30. Okay, so now we're going to solve for r, my radius. So the very first thing that I'm going to do is I'm going to multiply by 360 on both sides. So I'm going to get this over here. So a 12 times a 360 leaves us with a 4,320 pi. And then I'm left with the 30 pi r squared. Now I'm going to divide by 30 pi on both sides. My pi's are going to cancel, and a 4,320 divided by 30 leaves me with a 144. And that's equal to r squared. Taking the square root of both sides, I wind up with r is equal to, it cannot be negative because a radius is a length, so 12. It doesn't give me any units, so I'm just going to write 12 units as my radius. All right, this brings me to the end of this video.